Hey everybody, today we are going to start chapter 4 and we are going to start with section 4.2, which is classifying triangles. Now, most of these are going to be familiar to you. We've been classifying triangles for a little bit now. One of them may be a new term. So let's go ahead and take a look. Our first way that we can classify triangles is by their angle measures. So we're going to look at is what kinds of angles do we have. That will tell us what kind of triangle we have. So when we start by looking at an acute triangle, that means that all three angles in our acute triangle are going to measure less than 90 degrees. They will all be acute angles. We also have equiangular triangles. This might be the new one for you guys, a new terminology. Equa means equal, and angular is angle. So we have a triangle that has equal angles. All right. So in my equiangular triangle, all three angles are going to be the exact same measure. And they will all three be, so they'll all be congruent. When we look at our right triangle, that means we have one angle that measures 90 degrees. And with our obtuse triangle, we have one angle that's going to measure a degree that is greater than 90. And it will have one obtuse angle in it. All right. The other way that we can classify triangles is by looking at the lengths of their sides. The first way we can look at is if we have all three sides are congruent, that means my triangle is equilateral. If I have two sides congruent, my triangle is isosceles. One thing I want to point out is that it says at least two right here. That means equilateral triangles are also isosceles, but we will always call them equilateral simply because it is more specific and more correct. But know that an equilateral triangle, it's technically equilateral as well as isosceles. Just like up here with our equiangular triangle, all three angles are congruent, but they're also all acute. So an equiangular triangle is also congruent, or excuse me, is also acute, but it's kind of the same thing. Equiangular is more specific. All right, and then if I do not have any side lengths that are the same, that will be a scalene triangle. All right, so let's take a look here at our first example. I want to look at my triangles over here and I want to classify them by their angle measures. All right, so I am going to start by looking at triangle EHG. So I have EHG. So I am looking at the entire triangle right here. All right, so what I'm looking at is I notice that I have a 30-degree angle in this triangle. I have a 60-degree angle in this triangle, and I have a 90-degree angle in this triangle. So since I have a 90-degree angle, that means that I have a right triangle. Okay? All right, now let's look at our next one. Okay, my next one is triangle EFH, which is EF up here to H. So we're looking at this triangle right here. All right, so when I look at these, I have one angle measure that is 30, another angle measure that is 30, but I'm missing this angle measure right here. But what I want to notice is if I look at these two angles, this angle here and this 60-degree angle, if all I look at those two angles, so for just a second, don't scratch anything out on your paper, but for just a second, I'm going to kind of take everything else away. And if we look just at these two angles, you should notice that they are a linear pair, which means that they are also supplementary. So if I take 180 and I subtract 60 from that, I will get that this is 120 degrees. All right, so now that I know that this angle is 120, I know that it is more than 90, so it is an obtuse angle, so I have an obtuse triangle. All right, so let's take a look at examples with classifying triangles by side lengths. I'm going to start by looking at triangle ABC, which is this triangle right here. So what I can see here is it's already marked that these two sides right here are congruent. So I know that my triangle is at least an isosceles triangle. Okay, but then I'm going to look and notice that AB has a length of 15. But so does BC. BC is also 15. So that means that all three of these sides are actually going to be congruent. So that means that my triangle is equilateral. All right. All right, so the next one that we're going to look at is triangle ABD, which is this whole triangle right here. Okay, so it's the entire triangle all the way around the outside. And again, we're looking at all the different side lengths. So what I want to notice is that AB has a length of 15, AD has a length of 18, and BD here has a length of 20 because it's 15 and the 5. So this whole side length is 20. So we have 15, 18, and 20. So all three side lengths are different, which means that my triangle is scalene. All right. So if you have any questions on this, go ahead and write that down on your notes now. So let's take a look at our next example here. We want to find the lengths of all the sides of the triangle. We already know that our triangle is isosceles, okay, and we're going to use that information to find out what x is and then to find out the length of each side. So since these sides are marked as congruent, I can set these equal to each other. So I'm going to have 4x minus 1.3 is going to be equal to x plus 3.2. All right, so I'm going to, from here, subtract x from both sides. So this is going to give me 3x minus 1.3 is equal to 3.2. All right, the next thing is I'm going to add this 1.3 to both sides. So I'm going to get 3x is equal to 4.5. And then from here, we can divide both sides by 3. So I get that 4.5 divided by 3 is 1.5. So now the question that I'm asked is to find the lengths of the triangle. So I want to plug this 1.5 in for every x on each side. So let's start with LK. All right, LK is x plus 3.2. Well, we just said that x is 1.5. So then 1.5 plus 3.2 is going to give me 4.7. So there is one answer. All right, then we're going to move to JK, which is 4x minus 1.3. So I'm going to do 4 times 1.5 minus 1.3. Okay, and when I calculate that, I am going to get 4.7. So there's my answer for JK. And then I need to do JL. So JL is 5x minus 0.2. So again, I wrote a 5. Okay, JL. I keep wanting to write a 5 super early. All right, come on. JL is 5 times 1.5 minus 0.2. And again, when I do that calculation, I'm going to get 7.3. Okay. Come on. We're sticking here. Hold on. Sorry, guys. There we go. Bluetooth wasn't picking up. All right. So, any questions on that? We're using the fact that our triangle was isosceles so that we would know to set side lengths equal to each other so that we can find missing side lengths. All right. So, any questions? Go ahead and write that down on your notes right now. Okay. So, let's move on here. So here's what's going to happen here. We are still classifying triangles, and we want to classify them by their side lengths. All right, but this time, instead of actually having a picture with the triangle, we are given the coordinates of the vertices of the triangle. All right, so I know that my point P is going to be at the point 4, 0, Q will be at negative 3, 3, and R will be at 4, 6. Well, in order to classify the triangle by its sides, I'm going to need to know what the length of each side is. All right, so that means that I'm using distance formula to find the lengths of each of those sides. So I'm going to start by finding the length of PQ. So I'm just going to call PQ x1, y1 here for P, and Q I'm going to call x2, y2. All right, so I'm going to be, here's my distance formula. So my x2 minus x1 is going to be -3 minus 4. My y2 is 3 minus my y1, which is 0. All right, so this is going to give me the square root of -3 minus 4 is -7. -7 squared is 49. 3 minus 0 is 3, squared is 9, so that is going to be the square root of 58. All right, so let's look at QR. I'm going to go ahead and just leave Q as labeled x2, y2. It doesn't matter. And I'm just going to label R as x1, y1 now, since I'm looking at these two. So I'm going to do x2 minus x1, so I'm going to do -3 minus 4. And then my y2 is 3 minus my y1, which is 6. All right, so -3 minus 4 again is -7, and again -7 squared is 49. 3 minus 6 is a -3. -3 squared is 9. So again, we have the square root of 58. So at this point, we know that because PQ and QR are the same length, that our triangle is at least isosceles. Okay, we need to do the next one to see if our last side is also the square root of 58 to be equilateral. If it's something different, then we know we have an isosceles triangle. So let's take a look. I want to do PR. So again, I'm just going to leave R as x1, y1, and I'm going to make P x2, y2. So my x2 here is going to be 4 minus my x1, which is also 4. My y2 here is 0 minus my y1, which is 6. So 4 minus 4 is 0. Squared is still 0. 0 minus 6 is a -6, and -6 squared is 36. So the square root of 36, because that's what these are going to add to, is simply 6. So because 58, these two are both 58, this one is 6, I know two sides are the same length, so my triangle is isosceles. All right, because PQ is equal to QR, but those are not equal to RP. Okay, so PQ and QR are the same, but they do not equal RP, so I know that I have an isosceles triangle. All right, so again, I told you guys distance formula doesn't go away, so here it is now back in chapter 4. So please make sure that if you do not remember this formula, that you get it back into your brain because we're not letting it go. All right, so any questions on here, go ahead and write it down now. Okay, another way to tell whether or not we can use side lengths to classify a triangle by angles, all right? So if I want to classify a triangle as acute, obtuse, or right, I can still use the Pythagorean theorem, which we have already talked about, to determine whether or not what type of triangle I have. So a reminder that our Pythagorean theorem is a squared plus b squared equals c squared. And I don't know why I'm writing C. So this was our Pythagorean theorem. And remember that we used it to find missing sides of a right triangle, which was our distance formula from the beginning in chapter 1. So it's been a little bit since we've looked at it, okay? But so remember, a squared plus b squared equals c squared. Pythagorean theorem works for right triangles. So that's what this middle piece right here says. Okay, if our c squared is equal to a squared plus b squared, then we know we have a right triangle. Now, here's how we can use Pythagorean theorem to determine obtuse or acute triangles. I can set my c squared first. And then if I look at that and I see the length of my a squared plus b squared is smaller than my hypotenuse squared, then my triangle is going to be obtuse, because what happens is this side gets bigger and pushes this angle open. And I'm going to show us a little image of that here in just a second. If I go the other way with my C and I make my C a little bit smaller, okay, then I'm going to have an acute triangle. All right, so let's take a look at what this kind of looks like here. So here is a right triangle. All right, I'm looking at C squared. I want to compare it to A squared plus B squared. So in this case, my triangle measures side lengths are 5, 12, and 13. So this gives me a right triangle because 13 squared is 169, 5 squared is 25, 12 squared is 144. When these get added together, they equal 169. So my C squared is equal to my A squared plus B squared, so I have a right triangle. Let's look and see what happens when I open up and make that C squared longer. Notice that my A and B did not change. It's still 5 and 12. The only thing that I have changed is the length of that hypotenuse. All right, I've opened it up, I've made it bigger. Notice that this degree is now 124. All right, so when that C squared, this 237 squared, is greater than, not squared, but this 237, which is my C squared, is greater than that 169. Okay? If I take that and I make it smaller, notice that that creeps down farther and this angle now becomes acute. So now my C squared is smaller than my A squared plus B squared, and therefore my angle becomes acute. So that's what this slide here is saying. All right, if your C squared is bigger than A squared plus B squared, you're going to have an obtuse triangle. If your C squared is less than A squared plus B squared, then your triangle is going to become acute. All right, and then if they're equal, you have a right triangle. All right, so what we're going to look at, and one thing that I want you to write down on this part right here, is that the most important thing here is when you are writing this down, I want you to always write C squared first. All right, that's going to be super important that you are writing your C squared first, because what happens here, you guys see the obtuse or the greater than symbol, and you're going to automatically associate that with obtuse. But if you don't put C squared first, well, then you're going to look at this. You'll have A squared plus B squared is greater than C squared. Well, this is an acute triangle because look, C squared is less than A squared plus B squared. C squared is still smaller than A squared plus B squared. All right, if you put your C squared first, then your symbol is going to match what you're expecting of your angle measures, okay? So write C squared first. All right, let's do an example. Okay, so once again, we are given the coordinates of 3 vertices of a triangle, but this time I want to classify the triangle by its angles. So I want to classify it as obtuse, acute, or right. And again, to do that, I'm going to need to find the length of each side of the triangle. A reminder, and this is on your paper at the top, okay, that our distance formula is the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Okay? So I'm going to start with JK, and again, I'm just going to label this x1, y1, and x2, y2. So I'm going to do the square root of x2, which is 2, minus x1, which is a negative 1. So remember, subtracting that negative means we're adding. All right, y2 is 4 minus y1, which is 0. So 2 plus 1 is 3, squared is 9. 4 minus 0 is 4, squared is 16. This is going to give us the square root of 25. Now, this is 5, but because I know that I'm going to classify by angles, I'm actually just going to leave it like this, okay? I'm not going to worry about reducing any of these right this second. All right, next we're going to look at Km. So K is x2, y2, and I'm just going to leave that there, and I'm going to write M as x1, y1. So here we go again. My x2 is 2 minus my x1, which is 7, quantity squared, plus my y2, which is 4, minus my y1, which is 1. So 2 minus 7 is -5, squared is 25. 4 minus 1 is 3, squared is 9. This is going to give me the square root of 34. All right, then we're going to do mj. Again, I'm going to just go ahead and leave m as x1, y1. We're going to make j x2, y2. And x2 is -1 minus x1, which is 7, quantity squared, plus y2, which is 0, minus y1, which is 1. So 1 minus 7 is going to be -8. Squared is going to give me 64. And 0 minus 1 is -1 squared, which is 1. So this is going to give me the square root of 65. So now I have my 3 side lengths. I have the square root of 25, the square root of 34, and the square root of 65. So I am going to compare these. I'm going to take c squared and I'm going to compare it to a squared plus b squared. Now, one of the things that I usually do is, because I don't know what symbol I'm going to end up with, I usually just put a big black box on top of these because we don't know where we're going to go. Okay, so I just typically use a box. That way at the very last minute, I'll put in my symbol. Just, like those gray, like fill in the symbol boxes that you did when you were a kid. Same kind of concept here. We're going to fill in the symbol when we get to the end. But, you can leave the does that equals with the question mark on top of it. That's not a problem. All right, so my c squared is my longest side. So remember, c squared is always the longest side. All right, so my longest side over here is going to be the square root of 65. So I'm going to take the square root of 65 and I'm going to square it. All right, A and B, remember, it doesn't matter which side you pick to be A, which side you pick to be B. It's going to be the exact same thing. So I'm just going to make A the square root of 25, and we're going to square that. And I'm going to make B the square root of 34, and we're going to square that. All right? So the square root of 65 squared, we did this at the very beginning of the year. Anytime you square a square root, you're left with the number that's underneath. So square root of 65 squared is 65. Square root of 25 squared is 25. Square root of 34 squared is 34. So 65 is going to be greater than 59. Okay? So my c squared is greater. It is bigger. That means that that angle across from the opposite side is obtuse. Oop, can't spell. Okay, so it is obtuse. And that means that my triangle is also obtuse. Okay, so anytime that angle across from your longest side is the biggest angle, that's your obtuse triangle when that angle is measures larger than 90. So our c squared is bigger than a squared plus b squared, which meant we had an obtuse angle, which means we have an obtuse triangle. Okay, any questions on that? Go ahead and write them down now, and I will see you guys in class. Have a wonderful day.